Faces, so let me just say a couple words. Our workshops are jointly sponsored by the College of Engineering. Mark Urban Lorraine is representing over there. I'm in Briggs College, the College of Agriculture and Natural Resources, and the College of Natural Science. And my name is Saker Chahupla. I'm the Associate Dean for Faculty Development at the College of Natural Science. And today we have a special treat. We have actually an outside speaker for our workshop that I'm pleased to introduce. Let me get my notes so I do him justice. I promise I won't take long. So Dr. David Asai is the Director of Undergraduate Science Programs at the Howard Hughes Medical Institute. He and his staff oversee $80 million a year in funding initiatives for STEM education across the country, including, I'm privileged to say, a grant that we have here at Michigan State University. And they're interested in STEM teaching at research universities, at liberal arts colleges, and also, I think, interestingly engaging leading researchers in biomedical science in education. David has his undergraduate degree from Stanford, his graduate degree from Caltech. He's a cell biologist. He spent 19 years on the faculty at Purdue, with the last 3 as head of biological sciences there at Purdue. He was then Stuart Mudd Professor and Chair of Biology at Harvard Medical College for 5 years. He joined HHMI in August of 2008. As I think you'll see in his talk, in addition to his interest in STEM education broadly, he's a passionate advocate for addressing the lack of diversity in STEM education. Cool. The subject of his talk today, the title of his talk today is Race Matters. So without further ado, Dr. David Asai.
Thank you, Saker. Thank you. Good morning. How are you? Good. A little loud. I'm going to be showing a bunch of slides, and so I'm hoping the lighting and you all can see it. I'm so proud of my slides that I'm hoping that if you don't anything else, if you get nothing else from my little talk today, that you will appreciate my slides. One of my people showed me animations a few months ago. I didn't know you could do that. So now I know, and so you'll see what I have to say. I want to begin, though, with a couple of disclaimers. The first is that we'll be talking today about race, about ethnicity, about diversity. This isn't my area of scholarship, and so I have a strong passion for the importance of diversity in science, and I'm going to be sharing with you some data. I think many of you are already familiar with some of these data, but I just wanted to say that this isn't my area of expertise. And the second thing to say is that I recognize, coming back to a campus like this, which is a great experience for me, that the privilege I have of working at a place like Howard Hughes, where I can basically talk at you about what I think is important, but it's you who have to do the work. And so I recognize that position of privilege that I have here, and sometimes I get carried away and I get very enthusiastic and I like to have fun. And I hope that you don't think that I'm disrespecting the hard work that you have to do. The reality is very different sometimes than what somebody in Washington, D.C. thinks is going on. Although it wasn't too long ago when I was at another large Big Ten university. I want to start, though, with a personal story. This is Terminal Island. Terminal Island is located in Los Angeles Harbor. To your right is Long Beach. Los Angeles downtown is sort of up north. And Terminal Island is the place where a large number of the shipping containers come in from the Pacific. It's the largest port of entry on the West Coast. My father, before World War II began in 1941, lived on Terminal Island. Here's a picture of my dad. My father passed away last year in his 100th year. If you think about 100 years, he's seen a lot. A lot of things have happened in his life. But I'm showing you this picture to remind me about my father, but also to show you, here are those cranes that pick up the containers and offload the ships and everything. Anyway, that's what Terminal Island might look like today. But back in 1941, Terminal Island was a place where about 3,000 Japanese Americans lived. It was a fishing village. Most of them were either fisher persons or they they worked in canneries. They harvested sardines and so forth. My father, his sister, and their mother lived on Terminal Island. My grandmother ran a dry goods store. My father, by 1941, had already graduated from UC Berkeley. He had a degree in business, but there was no work for him in his field. And so he was working as a gardener in Long Beach. And of course, all of that changed when World War II happened in December of 41, because all the Japanese Americans on the West Coast were displaced from their homes and put into concentration camps. About 120,000 Japanese Americans. 2/3 of them were US citizens by virtue of birth, like my father and his sister. They didn't do anything wrong except for what they looked like. So they were put into concentration camps. My grandmother, my aunt, and my father ended up in a place called Poston, Arizona, which is right on the edge of Arizona and California. It's not too far from Lake Havasu, if you know that part of California. It's now even drier than it was back in 1941. And this Poston was the largest internment camp for Japanese Americans. It was there actually where my grandmother died. So she died at a very young age, before she turned 50. So this was her last home. Now, my father was brought up Buddhist, but in the camp, he became influenced by Baptist missionaries. And so he began to think about a career in the Christian ministry. And so from Poston, my father moved to Albion, Michigan, which is where the Star Commonwealth for Boys is. And he was a janitor there. And he also then began to coach a little bit of sports with the boys. And from there, then, he continued to pursue this idea about becoming a minister. And so he moved to Buffalo. And then finally, he entered seminary because ministers have to go to school to become a minister. And so he went to Andover Newton Seminary outside of Boston. He went there because that was the seminary that would take him. Because of his race, he was limited in terms of his opportunities. And so it happens that Andover Newton, back in those days, was producing ministers who went into the Congregational Church. And so by virtue of all of these sort of random things that happened in his life, he became a Christian minister in the denomination of the Congregational Church, which is a church which is started off in the Northeast, in New England. And if you know anything about the Congregational Church, you know that it's so called because there isn't a hierarchy. There's no bishops and all of this. So a Congregational Church is so called because the congregation gets to run things. The congregation pools its resources to hire their preacher. If you happen to be a rich church, you can hire a really good preacher. If you happen to be a small church, then you have to hire what you can get. My father, because of his race, because of what his background, ended up in very small churches throughout his career. So he started off in serving some churches in Vermont. This is where my brother and I joined the family. We then moved to a little town in Kansas called Partridge. I'll tell you how little it was. There were only 2 boys in my class, and when I left, Jim was on his own. And then finally in the 6th grade, we moved to Hawaii. Now, my experiences up until moving to Hawaii was, of course, we were the only ones who looked like me in my school or in our communities. We were indeed some of the only non-whites in the entire counties in which we lived. When we moved to Maui, it was a totally different experience. Maui, I was suddenly in the majority. So in the 6th grade, I suddenly became in the majority. In fact, there was only one haole in our class. And so it was an important experience for me. Well, enough about my story. The point that I'm trying to make is that for my father, race mattered. A large part of his life, where he could live, what he could do for a living, how he could raise his sons, depended on his ethnicity, on his race. It was defined for him. And so I want to talk today about diversity in science, and I'm going to spend most of the time focusing on race and ethnicity, not because that's the only way to define diversity, certainly not, but I think in terms of race and ethnicity, we in science have a long ways to go. And so this has been a very hard problem for us for a long time. And I think it's time for us to get better at working across differences. So race matters. And race matters for a number of reasons. First, race matters because it is our future. You know the demographic data. I don't need to show it to you. But the talent pool in this country is rapidly becoming diverse. Now remember, diversity is a property of a group. Diversity is not an individual. An individual cannot be diverse, but an individual can bring diversity to a group. And so when we talk about diversity, we're talking about, in this case, the national population. And you know these numbers. In blue is whites, non-Hispanic whites. In red are persons of color. This is the 2010 census data. The prediction is by the year 2050, this country will be a majority minority. If we look at who's growing the most, these now are in dark are the 2010 data. In the lighter purple are the 2050 census data, broken down by ethnicity, so white, Latino, African American, Asian American, and Native American. What you see is that the two largest groups in terms of growth will be Latinos and Asian Americans. And this is largely being driven by immigration. Now, if you think about diversity, this means that these folks who are adding to the persons of color in this country are bringing a very different perspective by virtue of the fact that they are derived from or they are themselves immigrants. So they have a greater distance in terms of how they think about things. And that's really good for this country. I'll finally remind you about a couple of numbers. In 27 years, in the year 2042, this country will be majority minority. Now, I may not live that long, but I was alive last year. Last year was the first year in which the population of students entering in K through 12 schools, in the public schools, were majority minority. So for a university, this is your talent pool. These are the people who will come to your university, and I hope will also teach at this university. Well, the second reason that race matters is that diversity is really important for excellence. If you're not familiar with Scott Page's book, The Difference, I invite you to take a look at it. There's also a terrific YouTube talk that he gave at UCSD. It gets into a lot of math and economics that I don't quite understand, but it's a wonderful presentation if you want to know more about how Scott Page thinks. So what Page shows is that a diverse group of problem solvers is actually better at solving a problem than a homogeneous group under certain conditions. And here are three of them. The first is that there are many smart persons who are working to solve the problem. So you need a large number of people, and the larger the number of people working on a particular problem, then the greater the benefit of having a diverse group of problem solvers. The second is that there are many different perspectives, tools, interpretations that can be applied to the problem. And the third is that as the problem becomes more difficult, then the benefit of diversity increases. So if you think about where science is today, most of the low-hanging fruit are gone. The easy stuff has been pretty much taken care of, well, at least in biology. I don't want to speak for the rest of you. The hard problems are still there. And so science fits these criteria very well. And I think Page would argue that we benefit, that we get better at solving this problem as a community if we have a diverse group of problem solvers. And so this is all good for science. This was said better in a movie. I don't usually go to movies, but I was in a hotel and I watched The Imitation Game a couple of months ago. This is the scene where, well, most of you have seen this movie, I guess. I'm only very late to this. So Joan Clark comes, you know, they had that, how many of you seen this movie? Do you know this? No, not a lot of you. Get a life, folks. So it's a story about Alan Turing, right? Academy Award nominee. Okay. So one of the problems was that they needed to solve this Enigma machine problem, and so Turing and his buddies put out a contest of crossword puzzles, and he figured that the people who were good at crossword puzzles would be the kind of people that they wanted to solve this problem. So they put out this national competition, and a bunch of people did really well, and so they come and they get invited to a room just like this, and they're all put into this room, and they all have to solve these problems, and all of them are white males. Joan Clark comes late, and she stopped at the door, and the person stopping her at the door says, well, you know, the secretary's tryouts are down the hall. And she goes, well, no, I'm actually here because of the crossword puzzle thing. You know, I'm one of the invitees. So they let her in. She kicks everybody's butt. She's the fastest. She's the best in terms of doing this. And there's a line from here which I just thought was really, really good. Sometimes it is the people who no one imagines anything of who do the things that no one can imagine. And so for me, this line is what Scott Page is trying to say. All right, so if you followed the argument, and I don't think there's, I suspect that many of you, all of you, agree with that premise, that diversity is important and that we need to do as good of a job as we can. So the question then is, if race matters, we're not taking advantage of the power of this diversity. And here are just some data. The US talent pool in terms of persons who are of working age is now about 30% underrepresented minorities. For underrepresented minorities, for the purposes of this talk, I'm talking about African Americans, Latinos, and Native Americans. So Asian Americans are not part of this group. So about 30% of our country is minority, but the scientific workforce is only about 9% minority. Here are some data over the last 10 years. So this is now PhDs in the natural sciences. You can use the same sort of graph and you would find the same sort of pattern if you included engineering, if you included all the STEM disciplines. We'll just use natural sciences. And I'm using PhDs not because we want everybody to become a PhD, but because this is one measure of how well we're doing in terms of developing our talent. And so over the past 10 years, from 2001 to 2010, the total number of PhDs in the natural sciences is this blue line, so it's gone up. And the percentage of them who are underrepresented minorities in the red line is also going up very slowly. The NIH over these 10 years has spent over $2 billion for this kind of a delta. Now, I'm not saying that they shouldn't have spent the money. They probably should have spent more. But what I'm also suggesting is that it's not just throwing money at this concern or this challenge that's going to get us to the next level. Here is a different way of looking at those data. Here is a population, percentage of the population that are minorities from 1970, and then it goes all the way out to 2110. So this is, the blue line is the US population in terms of underrepresented minorities from 1970 to about 2010. And here are the data that I could find for science PhDs in red. So the question is, what would it take for us to achieve parity in terms of minorities getting PhDs in the sciences? And let's do a thought experiment. Let's assume for a moment that the US population stops changing. And so the US population will be forever 30% minorities. Now that ain't going to happen, but let's just assume that will be the case. The question then is, how long does it take for the red line to intersect the blue line? And the answer is that somewhere around the year 2100 this would happen at our present rate. If we increase the rate by about threefold, then that line intersects at about 2050. But of course, by the year 2050, we know that that blue line is not going to be flat at 30%. We know that at 2050, that blue line will be well over 50%. And so that's our challenge. And the challenge begins at universities like this, not only because you're terrific, and you are, but because you're large, and you have some of the best talented students, and also some of the best faculty. So if we're going to make a change in this country, it has to happen at the large research universities. I think there's a huge impact that you all can have. And let me show you some numbers. The undergraduate years are critical. Here are some data from the NSF from a few years ago now. Again, we're plotting the percentage of folks in the particular category who are underrepresented minorities. And we're looking at 4 different kinds of categories. So the US population is about 30% minority. It turns out that the students entering college who are interested in studying STEM are also about 30% minorities nationally. So in fact, there isn't a real issue in terms of getting interest amongst our minority students who are entering college wanting to study science. The problem is what happens to them when they're in college. The baccalaureates are only 17% minorities, and the PhDs in the sciences are only 9% minorities. And you all know, we all know, that it's the undergraduate time when a student will find her identity as a scientist, when she will develop some of the skills that will take her to a degree like the PhD. And so I think that these data say that we need to do something about this at the undergraduate years. So as I said, the research universities have a high potential. And here are just some data from a few years ago, actually, of the 203 research universities in this country. So there are 203 very high and high research activity universities as classified by the Carnegie Foundation. Michigan State is certainly one of them. And then there are the 60 AAU universities that are in the United States, and Michigan State is also one of them. So here are just some data. The total enrollment, at least a few years ago, in the 203 universities, for example, was 3.3 million. Over 590,000 were underrepresented minorities. That's 18% of the enrollment. In the AAU schools, you see this. So that's a huge capacity. There's a huge potential here. If we look at science baccalaureates per year, so the number of kids who actually get a baccalaureate in science, 73,000 from those 203 universities, and 9,000 of them, or 12%, are minorities. Again, there's a drop-off, but that's still a large number of minorities. So now I want to talk about yield. So if we look at the science baccalaureates per year that have been produced by these universities, and we ask how many of them go on for a PhD in the sciences, we're going to call that the yield. And here are some of the numbers. So for the 203 universities, or for the AAU universities, all of the students, regardless of race, about 5.7% of the baccalaureates go on for a PhD. AAU schools, as you would expect, maybe, it's higher, 8.3%. But for minorities, 3.1% and 4.9%. But what about Michigan State? So Michigan State's numbers are 5.5% yield for all students and 2.5% for your underrepresented minorities who are graduating with a science degree, a baccalaureate degree in science from this university. And so you're the same as these other folks, which is what you would expect, I suppose. But I would suggest that there's something that we need to think about in terms of the differential yield that's happening across the country and on this campus. All right, so how do we react to these data? How do faculty react to these data? And I still identify as a faculty member, so this is not a time when I'm telling you what you're doing wrong and I know the answer. I don't know the answer. I understand how one reacts to this stuff. And here's a couple of reactions that occur to me. One is, well, our general reaction tends to be to blame someone else. There's a different version of this which says keep calm and blame the victim. So here's a couple of answers or a couple of ways that we rationalize these data sometimes. We might say it's not my fault. The students are not prepared for the rigors of science. So if you talk to scientists at other universities, they'll say, if the student was prepared, I could do a great job because I'm a great teacher. I'm a great lab mentor. But the student's not prepared. If the student is a graduate student, well, it's the undergraduate preparation that was inadequate. If the student is an undergraduate, it says, well, the high school wasn't so good. The high school says, well, the middle school wasn't so good. And so we tend to pass that along in terms of, well, figuring out who's responsible for this problem. And so that's sort of the first argument that we might make. The students are just not prepared. And the second, which is a corollary, is, it's really for their own good, after all, that we exclude them from these the very highest universities because they just don't belong here. They're just not good enough to succeed. So if this is our response, then how do we put those responses into action? And again, I'm trivializing a lot of what the hard work that you all are doing, but I'm talking about other universities and not you. So if most of the students, so the premise, right, the assumption based on our excuses is that they're not prepared and they don't belong here anyway. So what do? Well, what we do is we create gateway courses. And the gateway course sounds really good, right? Because it's a gateway and you walk through the gate and there's the promised land and you just got to take care of you got to get the basics down and then you're ready to succeed. So here's what really happens in our current approach nationally. We start off with a hypothetical group of 100 students. 30% of them are underrepresented minorities in these yellow circles. We put them through the gateway courses, which typically take place in the first year of their undergraduate experience. And the data are that this is what comes out of those gateway courses. We lose 60% of all of the students who come in and 80% of the minorities. Now think about our business model for a moment. It turns out that nationally, over 40% of all students entering college want to study STEM. That's 1.5 million or so people. So our business model is good, right? We don't have to gin up the interest. There's already a heck of a lot of people who are interested. But once we come into college, we basically weed out well over half of all of the students who come in. And for the minorities, it's a really bad number. And so instead of the gateway, this promised land, it becomes more like this. Now, I have fun with these things. I know it's not that easy to just change the gateway courses, but this is what we're seeing nationally. So what are the data? Let's go back to those two excuses that we often use. They're not prepared. Well, is it true that they're not prepared? Here are some data from a 2000 study in which these folks looked at a large cohort over 8 years prior to the study, and they asked two questions. The first question was, what sort of predictors, what sort of characteristics are of students who are successful in STEM once they get to college? And then the second question is, once they get to college, what happens to them? So the first part of the study said what you would expect. Some of the characteristics that make for a successful student in STEM in college, before she gets to college, is she has to go to a high school that had something more than Algebra 1, that there were labs with at least one of the science courses, and that she comes from a family that values a college education. They don't necessarily have to have been to college themselves, but they want her to go to college. The second part of that study then is they looked at these 17,000 or something students who went into college, and they asked after 5 years what happened to them. They all started off in STEM. And so they were able to put the outcomes into 4 different bins. The first group is those who complete. So they started off in STEM, and they majored, and they graduated with a baccalaureate in some STEM discipline. The second group are the persisters, those who haven't yet graduated, but they're still in their major, the major that they started off with. The third are folks who switched. So they started off in STEM, but then they switched to another non-STEM discipline. And fourth, those who dropped out of college. In the dark blue are whites and Asians, and the light blue, light purple are underrepresented minorities. And I hope that you can see a couple of things from these data. The first is that the flunk out rate, if you will, is about the same for both groups. So it's not that the minorities come to college and they're just not able to finish at our universities. But the other thing that you notice is that the switch rate is about 2.5-fold that for minorities than minorities. And when you control for those factors that predict success in STEM, the algebra, more than algebra in high school, the labs, the family, you find the same kind of disparity in the data. So I would suggest that these data suggest that we need to do something more once the students get to college. It's not just their fault that they're not good enough to complete our science courses. Well, here's the other excuse. You know, it's just for their own good. They don't really belong here. They're not going to succeed. And so they just shouldn't be coming to places like Michigan State because, you know, this is for people who are going to be successful, and these students are not. And so that really reminds me of something that Justice Clarence Thomas has written about a lot, which is called the mismatch hypothesis. Now, if you've read any of Justice Thomas's work, you know that he likes to talk about this a lot. This happens to be a quote from the Fisher versus University of Texas affirmative action case that was decided a few years ago. This is Justice Thomas's concurring opinion. And if you read this, the concurring opinion is quite a bit longer than the opinion because he really likes to go off on this stuff. So here's one little section of his thing. The underlinings are mine. I'm just going to read this for you. So as a result of the mismatching, many blacks and Hispanics who likely would have excelled at less elite schools are placed in a position where underperformance is all but inevitable because they are less academically prepared than the white and Asian students with whom they must compete. So he's making two assumptions here. First is that if you are mismatched, you're going to fail. And second, for some reason, the mismatching works worse or better for Hispanics and blacks than it does for whites and Asians. So there are some data that actually address this question. And the data came from a study by Kurlander et al., Kurlander and Grodsky, in which they took advantage of a glitch in the University of California system. Now, the University of California has lots of glitches. And so this was just the one that happened a few years ago. You know that the University of California is the flagship system in the state of California. You know that there are three systems in California, right? There's the UCs, there's the Cal States, and then there are the community colleges. And they're all organized throughout the state. If you're really good, you can get into the UCs. The UCs, though, there are several campuses, as you know. There is also a hierarchy amongst those undergraduate campuses. So if you're really, really, really good, you can get into one of the three elite UCs, Berkeley, San Diego, and Los Angeles, UCLA, UCSD, and UC Berkeley. If you're good, but you're not really, really, really good, then you can get into some of the other UC schools. And at that time, Merced hadn't yet been created. And so Davis, Irvine, Riverside, Santa Barbara, and Santa Cruz. So back in the year 2004, the University of California had a glitch in which they didn't have enough money, which is a recurring theme at the University of California, to seat all of the students who could have come into the UC system. And so what they did was they created something called the Guaranteed Transfer Option. 2,300 students who were in the entering class in 2004. They were all good enough to get into the UCs, but of course only a few of them were able to get into the elite schools, and the rest of them would have been put into these other almost but not quite elite schools. And for these 2,300 students, they said, hey, you get a choice here. We're going to put you in a community college for a semester or so, and then you can come into a UC campus, but you can choose the UC campus that you want. So even if you weren't good enough to get into Berkeley or UCLA or San Diego, if you so choose, you can go there. And so 491 students chose to do this. These are the GTO students, or the mismatched students by Clarence Thomas's terminology. So the question is, well, what happened to those 491? And the answer is, if you look at the GPAs of those students, they were statistically the same as those who would have gotten into Berkeley, UCLA, and San Diego anyway. If you look at their dropout rates, they were no more or less likely to drop out of the elite schools. Actually, the GTO students, these so-called mismatched students, were actually less likely to drop out than their peers who chose the non-elite schools. And finally, if there is a mismatch, there was no differential in terms of blacks and Hispanics and Asians and whites. So it's these kinds of data, I think, that we need to become familiar with to begin to address some of the arguments that we often hear. So I would suggest then that there are ways that we can change. And I'm going to suggest that a lot of this change has to do with the people in this room. When I go and give this talk, or something like this talk, I like to talk to faculty because I was once one of you. I'd love one day to become, again, one of you, but right now I'm not. So I look up and I look at the group of you that have this opportunity to be faculty. And I think that we faculty can do a better job in terms of taking some of the responsibility for working with our students. You can call this professional development, but I think that this is something that we just need to learn how to do better. And so let's talk about some of the change that we can affect. We could change the way we teach. So some of you may have seen this next sort of series of slides. This is the way many of us at many universities are currently teaching, especially our introductory courses. You have the lecture, you have students in the class. If you look at this particular picture, there are several students who are very much older maybe than some of the average students, which means that they've been there a long time. Nevertheless, this is sort of what it might look like. This is what it looked like at Purdue. I taught a course for 450 introductory cell biologists every fall. If you take a look at what the students are doing, this happens to be from Dublin, I think. This is a picture I grabbed off the web. Here are all the students, and of course, what's unusual here? Say again? No devices. Yeah, for some reason, they all knew they were being taken. No, there's nobody texting or they all actually seem to be awake. So that's what's happening in the 21st century. And of course, in the 14th century, you get a picture like this, which is real similar, right? So she's texting, and these two are talking about what they're going to be doing tonight. You got the red hots up in the front, right? They're all reading, right? Here's the lecturer up here. You get this guy's taking a nap, and so forth. And so the point is, and Scott Freeman uses this much better than I, the point is that we really haven't changed at many places in terms of how we teach. Now, we know that active learning works. There's been a number of papers now that have shown this. You can take a look in the STEM disciplines. And I don't think it's any surprise to you. And I had a chance to go to the Lyman Briggs College yesterday, and I was able to watch some of the lab courses going on for both the honors students and the Lyman Briggs students. And so we get it. It's not like this is new for you all. But we know that student research is a particularly important way to engage students in active learning. And if you think about student research, there's sort of two ways that undergraduates can engage in research. The first is what I'll call apprentice-based. So apprentice-based is what I did. When I got to college, I found a poor professor and convinced him that I was going to work in his lab. And so actually I had a chance to work in Dow Woodward's lab for 4 years. Every quarter I was at Stanford, every summer. And this was a great experience for me. And of course, a lot of students do this. But it's also very expensive. The other approach is what I'm going to call a course-based experience, or a CRE, course-based research experience. And so here are some of the characteristics of these two. The apprentice-based approach, which I think many of us are familiar with, is expensive because it involves a large number, a small number of faculty with a small number of students. Right? So Dow was my mentor, and he put me together with a graduate student and a postdoc, and there were a few other undergraduates in the lab, but this was not a scalable approach. It's also, of course, very time-consuming, and it can be expensive. As you know, many of our summer students, whether they're in an REU program or if they're being funded by other places like HHMI, students get a stipend, which is important for them. HHMI spends, we support about 10,000 students, about 4,000 students every summer through our various grants at other places. And our average cost is something like $10,000 per student. So it's expensive in time, people, and dollars. The other thing, though, is because it's expensive, it tends to be based on selection. So when you've got a student who wants to work in your lab, because it's expensive, because it's going to take time, you might say, you know, how'd you do in your introductory courses? Did you take genetics yet? Come back when you're a junior. I might have a slot for you there. Now, I know it doesn't happen here, but it certainly happens at other places like that. The other approach to course-based research experience is that it could be, in theory, scalable. So you could take an entire class, 20, 24 students, with one faculty member. And because you can do it early, and the course I'm going to talk about is a freshman course, it can focus more on the identification and development of potential as opposed to selection. And if we're thinking about how we will add diversity to the scientific workforce, I think we need to think about a broader approach that looks at all students as opposed to a one that depends on selection. So some of you know that we have been running something called the PHAGES course for the last 7 years. We're about to enter our 8th year. PHAGES stands for Phage Hunters Advancing Genomics and Evolutionary Science. It was developed by Graham Hatfull at the University of Pittsburgh. And very quickly, what these students will do is they're looking for viruses that infect bacteria. Turns out that the viruses are the single largest repository of biological diversity on the planet. There are 10 to the 31 phages on the planet, and they turn over every 20 minutes or something like that. So it's a huge question in terms of evolution and genetic diversity. What the students do is they go out and they learn how to isolate bacteriophage. And so they scoop soil, they isolate phage, they look at them with the electron microscope, and at the end of the first semester, the students then isolate, they purify a population, their phage, they isolate the DNA, they then give us the DNA and we sequence the DNA. In the spring semester then, they come back and the students then annotate those genomes. So they look to see where genes might be in this genome, and at the end of the spring semester in June, we have a symposium in which students come and they present their work. This stuff has terrific implications in terms of the science. Now, over the years, as I said, we've involved this with a large number of students. This particular academic year, we have over 2,700 students. Most of them are freshmen at 74 different schools. Next year, we're going to be adding 17 more schools. Up to date, or to date, the students have identified something like 48,000 genes. 865 of them are novel. And importantly, they've doubled the number of clusters, that is, the genetic groups that come about because of the analysis of the genome sequences. And so we started off 7 years ago knowing about 9 of these clusters. We now know about 18 of these clusters. 82% of all the sequences that are in GenBank come from these students, and we've published now something like 19 papers. More importantly, perhaps, is that we've also looked to see how the students do in class and whether they stay in science. And what we find is that the students who take the Phages lab course, when compared to students who don't take the Phages lab course at the same institution, do better in terms of their grades in the lecture course, and they also tend to stay in science or in school. So let me repeat that, because I didn't say it very well. You know, at many places, an intro bio lab would be closely connected with whatever's happening in the lecture. And so if the lecture this week is talking about, say, enzymes, then in the lab, the students would do an exercise with beta-galactosidase or something. And next week, they might talk about genetics. And so in the lab, they might look at fruit flies. And then next week, it might be about photosynthesis, right? And so there is, at many places in this country, the dogma that you have to connect the lab and the lecture course very closely, because this is the way students learn. So these data that we've studied, that we've attained with our students, are with students who are taking the Phages lab to replace the normal Bio 1 lab. And so they're not doing the stuff that they're supposed to be doing this week, but rather they're just pursuing this research question. And so that's the basis for this study. This was published last year. So the interesting thing for me, now that I work at Howard Hughes, is what does it cost to do this? Because it is expensive. You have to provide supplies for the students. You do electron microscopy, you sequence DNA. You provide a lot of software. We do a lot of faculty training. And so our estimate is that it costs between $150 to $200 per student for supplies. And this excludes salaries. This excludes TAs or faculty salaries. That's a large number. So for a large university like Michigan State, that would be a huge number if you wanted to involve all of your freshmen in a lab course like this. But I just wanted to compare this to what we spend on students who are doing apprentice-based research. So for apprentice-based research, that can cost up to $10,000 per student. So we did a study, a non-scientific study, in which we asked 17 research universities. So these are the very high research universities in the country, both public and private universities. And we simply asked them, how much do you spend per student on your introductory lab course, excluding salaries? And we got the following number. So with the 17 very high research universities, the average was $56 per student. The range was $10 to $337. Now here's where I get excited. I get it that budgets are tough and that it's hard to spend lots of money on things like education, especially on introductory courses. I get it that that's been our philosophy, because after all, 60% of those students won't be past the introductory course anyway, so why spend all this money on them? But I'll look at it from the other way. These students are coming to a research university. These are very high research universities. Presumably, there's good research going on at those universities. And so I wonder if it isn't our responsibility to make sure that those students get exposed to research, even in the introductory year. Because most of them won't be beyond, they won't know anything except the introductory year. Or the other way of thinking about this is that if it's $10 on the low end of this range in my survey, this is what $10 can buy. So I would suggest that it's important for us who think about what's happening at the research universities to thinking about flipping the formula. The fact is that the first science course that most students are taking is also the last science course. It's not just for those who come in wanting to study science, it's for all those who know they're not going to study science, but they need to take one course in science to fulfill their gen ed requirements. And so all of these students, we know only a few of them are going to stay in science. Many of them are going to go and become lawyers and politicians and teachers and journalists and everything else that students can achieve. And I really want them to have a good experience if they only take one science course. And as you know, the data are that the students who leave usually are not very happy with their experience in science. All right, the second thing that I'm going to suggest that we need to do as faculty is to change our skill set. And I think we need to intentionally train ourselves to work across differences. When I was a postdoc, I decided that I needed to know how to make monoclonal antibodies. And so at the time, we weren't making monoclonals in the lab that I was a postdoc. And so I spent 2 weeks as a postdoc. I went off and visited a colleague somewhere else, and I learned how to make monoclonals. And this was time that I had to spend, but I knew that this was going to be important for my career, and it was. And so it was just an intentional way for me to train myself in the skill that I didn't have when I was beginning to start off on my career. And I would suggest that we need to do the same thing in terms of how we teach and how we think about difference in our classrooms and in our labs. So working across differences. The data nationally is as follows. About 30% of our students are underrepresented minorities. Tenure-track faculty at universities are in science, in STEM, are about 6% underrepresented minorities. So there's a good chance that just based on ethnicity and race, that a faculty member is going to be working with students who don't look like her. Here's another interesting piece of data. This is from Angela Byers-Winston and her colleagues at the University of Wisconsin. They look at dyad mentoring. So they look at a mentor and a mentee, and they ask them what's important for you. So if you ask the mentors in blue and the mentees in red, is it important that you be the same race? And about 35% say, yeah, it's important that we be the same race. If it's important that you be the same gender, yeah, it's about 35% of both groups. But when you ask, is it important that you be able to talk about difference? Almost all of the mentees in red say, yep. But the mentors are not able or reluctant anyway to do this. So I think we need to learn the skills of how to do this better. So developing the skills to work across difference. And I'm just going to suggest that there are 3 things that we could work on. The first is to understand implicit bias. The second is to understand expectations. And the third is to understand privilege. We all have them. We have them all. We can't live without them. We're not going to fix it by getting rid of our bias or our expectations or our privilege, but it's important for us to understand that we have it and that the students are in a different relationship in these 3 ways. So very quickly, implicit bias. I don't know how many of you saw this when George Stephanopoulos was interviewing Officer Warren, is that his name? Was that? Wilson? Darren Wilson, you know, from the Ferguson case a while back. And Stephanopoulos asked Wilson, well, you know, would you have behaved any differently if the victim was a different race? And Wilson said, no, of course not. I'm not biased. Well, if it's true that he's not biased, he will be the only person in this country who is not biased. So here is just some data, and you know about these sorts of studies. These are the so-called Goldberg variations or the Goldberg approach protocol. Here's just a few of them. This was published several years ago now. Basically, the Goldberg approach, as I understand it, is that you make up a fictitious CV or you make up a fictitious application or whatever, and the only thing that you change is the name. And so in this particular case, this was an IT job. I think it was in Cleveland. And what the study basically did was they made up a fake CV, a fake resume, and these people then applied for this IT job. And the question was just how many times did you have to apply before you got an interview? And the only difference in these fake CVs was the name. So sometimes the name had Emily or Ann, Greg or Matthew. Sometimes the name was Aisha or Keisha, Leroy or Jermaine. And the answer was, as you would expect, it took about 1.5 times more submission before you got an interview if your name happened to sound like you were African American. Here's another example. Well, that of course was in the IT business. That's not faculty. Faculty are better at this sort of thing. So here was a study done last year by Kate Milkman and her colleagues. In this particular case, they did the same sort of thing, but instead of an application for a job, they asked faculty at 259 universities, 6,500 faculty, would they meet with a fictitious student who was interested in studying with them as a graduate student. And again, the only difference was the name on the email. So sometimes it was Brad Anderson, sometimes it was Raj Singh, sometimes it was Lamar Washington, Keisha Thomas, and so forth. And the question was simply, will the faculty members agree to meet with this fictitious student or not? And the answer was very clear, that the faculty ignored the requests from women and minorities at a higher rate than requests from white males. And second, that the response rate actually got worse with the higher paying disciplines and with the private elite universities. And that there was no difference in terms of the response rate if the responder, if the faculty member was male or female, majority or minority. So again, this suggests that faculty have biases as well. Well, okay, that's fine, but that's not science. Scientists are objective, right? So we can't be, well, actually, so the Moss-Rakusin paper is an example of this, another variation of this particular protocol. In this case, they approached, these are life scientists, they approached faculty with an application, a fictitious application for a lab manager position, and this was simply a male versus female fictitious person, and then they asked the lab PIs to rate the applicant based on competency, hireability, worthy of mentoring, and starting salary. And the data are these. In male, the blue are in male, that is if the fictitious person was male, and red are female. And in every case, the females were ranked lower, starting salary, mentorability, competency, and so forth. And so again, this would suggest, and they conclude, that we scientists are also have implicit bias. So that's what we have. And the question isn't to cure us of that. The question is to acknowledge that we have that. Molly Carnes at the University of Wisconsin and her coworkers have written extensively on this. I don't have time to talk about this, but you should take a look at some of their work. And they have an intervention, which is wrapped in a workshop of about 3 hours, in which faculty, science faculty, can learn what it means to have implicit bias and then how you counteract that. And the counteractions are personal decisions, that you have to recognize that you are stereotyping, that you individuate as opposed to generalizing, and that you seek out opportunities for increased contact with the person, with the group that you've stereotyped. So that's implicit bias. The second thing that I think we need to understand that we have are expectations. I recently bought an ukulele because I grew up in Hawaii, so I thought I should learn how to play the ukulele. I don't know how to play the ukulele. I've tried it, I'm just no good. But I bought an ukulele online, and I bought one that was more expensive than the cheap ukulele, because I assumed, somewhere deep in my brain, that if I got a more expensive ukulele, I'd be better at it. It would sound better. Now, you may think that's funny, but in fact, recently, and maybe some of you saw this, there was a study on a Parkinson's drug where the placebo was priced at different levels. And so the result was that if you offer, so there was 3 variations, right? You got the actual drug, the treatment, and you get a placebo or the same placebo, but the patient is told in one case the placebo is like $10, and the other case the placebo is $1,000. And the effect was that the more expensive placebo had a greater positive effect on the MRI, as measured by MRI, of the patients. And so again, this is an expectation. Well, what do we do in terms of our scientists, our young scientists who are minorities? And there are very little data on this, but here is one set published by Mike Nettles and Catherine Millett. They asked simply of the science graduate students, how many of them had published a peer-reviewed research article based on their research as a graduate student? Whites and Asians reported that 48% of them had published something. International students, 40% had published. African Americans, 17%. An interpretation of this, and one that Mike Nettles favors, is that this is another example where faculty have lower expectations for some students. Another way of saying that is, they don't really belong here, they're lucky they're here, we're going to get them through. Well, you and I know that if you don't publish, you have no future in science. And so we're not doing anybody a favor if these data are the same. And by the way, as I said, there's scant data on this. And so if you all know of anything, this would be really interesting. We have other data that corresponds to this, but it's not been published. All right, so the last thing that I want to talk about then is privilege. And I have fun here, and we can talk about privilege all day. A privilege, of course, is just another thing that we all have. We can't live without it. Any relationship, there's a person who has privilege and there's a person who has less privilege. So here's just some examples. Faculty privilege. I used to teach Bio 231 at Purdue. This is a large cell biology course. I wrote lots of letters of recommendation for students who wanted to go on. In this case, she wanted to go on to medical school. And so I went back and I actually retrieved one of my letters. And you can tell what my office looks like. And there were 2 paragraphs in the letter, and this is the longer paragraph. And I'm just extract just parts of this longer paragraph here for you. Our course is a rigorous attempt to link molecular structure with biological function. All exams are answered with short essays or calculations. No calculators permitted, exclamation point. The emphasis is on precise problem solving. For many, Bio 231 proves to be the weed-out course. This is a letter of recommendation for a young woman who's applying to medical school. So it's all about me. It's not about her. This is a version of privilege. Here's another example. In this country, if you are not white, male, heterosexual, Christian, then you understand how it feels to be put into a group. And sometimes when we are thought about as a member of a group, then people will tell us how they know how we feel. Well, I live near Washington, D.C., and so we have sort of a professional football team, and they have a mascot. And if you've been following the news at all, you know that there's a lot of controversy here, and they're not going to change. And they're not going to change because they feel that, the majority of people, it's okay with them. Here's just some quotes. I don't have time to read it all, but here's the guy who owns the thing, Dan Snyder. That the name really means honor, respect. We sing hail to the Redskins. Here's a former player, Hall of Fame. When I came it was elation in the reservations. They loved the fact that I was playing for they considered it an honor. And so these guys are telling us how we might feel. The Native Americans might have a different opinion. So this is a version of privilege. Now I'm not Native American, so you might think, well, so what? It wasn't too long ago when the Pekin High School in Illinois had as their mascot the Chinks. And online you can find an interview with Bob Brown, who was the 1960 Chink. And he says, it was a great honor and still is to me today. Another girl in my class was voted Chinklet. We wore Chinese costumes and greeted cheerleaders. It was a gesture of a welcome and good sportsmanship. And so these kinds of things, when people are telling me how I feel, is a form of privilege. And we do it all the time, and we don't mean bad by it, but I think it's important that we recognize that in ourselves and the way we work with our students. Here's one more example. Another form of privilege, especially you see this in the STEM disciplines, is you say, well, I'm an individual. I made it by pulling myself up by my bootstraps, and so should you if you're any good. If you're any good, you're going to do it just like I did it. Right? Here's a cartoon that illustrates this in a different way. And again, this is this idea about thinking about an individual versus a group. So the cartoon says, here's two guys and they're doing math or something, and the first guy says, well, you really suck at math. Okay, that's an individual. But if it happens to be a girl, well, girls suck at math. So this is that individual versus non. Okay, do we have time to do an exercise? Are you up for this? I'm sorry I've been talking at you for so long. And I could go on. I took out a lot of stuff, but Sekar said I only had 5 hours with you, so that was good. All right, so there's a group, Barbara Berry and Janice Eddy, Bill Page, and others. They've been doing these workshops on diversity. I've done now 7 of these with them. We started off at Purdue. I did it at Harvey Mudd. I've done it at Howard Hughes. I did it at the University of North Carolina. These are 2.5-day workshops. They're long. There's a big investment of time, but what you learn are the skills of listening and about being motivated by feelings as opposed to just intellectualizing something. You happen to be talking about race because race is a really hard thing for us scientists to talk about, but it doesn't have to be about race. And in fact, what comes out of it are thoughts about how we can teach better and how we can think about our students better. It's not just about race, but it engages you in the topic of race because race is so hard. So anyway, Barbara does this exercise when she talks about privilege. And so I'd ask you to think about this, and I'm going to have a second slide here in just a second. So privilege, remember, is a relationship, in this case, between two people. And in each case, depending upon the dimension, one person will have privilege over the other, but in a different dimension, it might be reversed. And so she talks about it in terms of one up and one down. If you're the one up in a particular relationship, you have the privilege. So you might be oblivious to the needs of the other person. You might assume knowledge of the other person's experience. You might have limited awareness of your own behavior. You might preserve your own comfort. You seek to control, and you tend to be silent when you see things happening to the other group. If you happen to be in the down position, so you don't have the privilege in the relationship, then she says that we tend to study the one-ups, the people who have the privilege in a particular relationship. And you all know what I'm talking about because we all study those who are above us. We tend to accommodate, we adapt, we assimilate, we seek confirmation, we look for survival, and then often it plays out in terms of horizontal violence. So what I would ask you to do is I'm going to ask you to do an exercise. I'd like you, and most of you have something to write with, I'd like you to just think very quickly about one example in your life, you personally in your life, in which you are in the one-up position. You have privilege. And then I want you to think about another example in which you are in the down position. You don't have the privilege in that relationship. Does that make clear? So please, because I got more for you, so you got to write it down. Please. This is like my classroom. Everybody must do it or there's no dessert. Just jot it down. There's no right answer, obviously. Nobody's going to collect this. It's just for your own notes. So a situation in which you are the one up, a situation when you're one down. Ready? Not yet? All right, do most of you have something? Yes? You got to work with me here, guys. Come on. Okay. I appreciate the fact that you're playing with me. So normally this would take an entire morning, and we're going to do it in a few minutes. The second part of this exercise now is what we're going to do in just a minute, don't do it yet, is we're going to pair off, and you're going to talk to one another, and you're going to be talking about one thing. So each person in the pair is going to say, and I'm only going to do this as a partial exercise. So each of you will take turns talking about the one down situation that you put on your list, no matter what it is, and how it felt to be in the down position. Okay? And then after the first person has talked, we'll give you a couple of minutes, and then the second person will talk. But this isn't just talking, because this is now the second part of this exercise, which is usually another whole set of exercises that we don't have time for. And that is to practice listening to understand. So as you all are pairing up, so if Jerry and I were paired off, and it's Jerry's turn to talk, and it's my turn to listen, there are certain rules about listening, and I want you to try to follow this. Now, I'll tell you that grade school kids are really good at this, and faculty tend not to be so good at this, but you will be the exception. So my job as the listener, if it's Jerry's turn, is to give the speaker my undivided attention, which means only he gets to talk, and it's my job to listen. I should make eye contact with him, and my body language should be one of being listening, that rather than, oh yeah, I know they are. It is not my story. It's not my opportunity to tell Jerry, oh yeah, that happened to me too. It's Jerry's turn to tell me whatever he wants to tell me. And so for those a couple of minutes, I need to look him in the eye, I need to make good eye contact, my body language should just be, I'm here to listen to you, and you get the full time allotted to you even if you run out of things to say and the 2 minutes are not up yet. So during those 2 minutes, or the end of those 2 minutes, if Jerry's done talking, we're just going to be looking at each other. But he might have something more to say, and I should be there to listen to him. And finally, this is different, right, than a normal conversation, because I'm not going to now discuss what Jerry told me or change my story based upon whatever he told me. So that's really hard. So what we're going to do is you're going to pair up. We're going to give each side, each person, 2 minutes. It's going to get very noisy in here, but that's okay. I want you to practice these listening skills. Remember, the assignment is simply to tell your partner one situation in which you were in the down position and how it felt. And I want the listening part of it to be practicing these listening skills. And then after 2 minutes, and I'll call the time, you're going to flip. Doesn't matter if you're halfway through or whatever. Just shut up, and the other person talks, and we'll go for another 2 minutes. Is that clear? I would love it if everybody would participate, and I don't care with whom you partner, but please do it right now. Ready? And start. Begin. I love you to debrief just a little bit with the group. It's not about what you talked about specifically. We don't want to know the content here. Everything that goes on here stays in here, in this room. But rather just the process. So the pedagogy of all this. Content, no. Pedagogy, yes. So any thoughts? How'd this go? All right.
So my question was about whether it was 2 minutes, because it
was
too
2
long.
Hi, I agree it is like it was longer than 2 minutes, but I think it was almost a little bit therapeutic to be able to kind of talk through some of the things you were feeling without someone else necessarily responding. It gave you the chance to think it through and maybe come to some realizations as you were explaining how you felt when you were in a down position.
Thank you. Another comment. Gentleman back there.
Yes, it was interesting that no matter who we are or who we've been, at some point we were in the one down position.
Good. Yes, sir.
It was very hard for me not to say something when I was listening.
Right. So I was watching you all listen, and you get about a C as a group. So passive listening involves, I'm not doing this. I'm really, and it's really hard, right? Because that's not our culture. And I'm not suggesting that that's how you go through life, not being totally stoic about everything. But part of the exercise is how hard it is to listen. It's a skill that has to be developed. Thank you. Other comments or thoughts? Yes, sir.
I have a question to follow up there. I didn't get the stoic part, so I was one of the people that failed that. So
I didn't say that, Corey.
no, I know. I was shaking my head and that sort of thing. How does that play into it? So I always feel like that kind of thing is encouraging, but you're suggesting that we should be more passive in the listening?
So as I understand the exercise, and this is one of the valuable things that I get out of this workshop, is these listening skills. It's not that that's how I should behave, because you do want to engage, but what you first have to do is to just drop all that, because it's really not for me to be putting into my life your story. It's about you. And so I have to be disciplined in terms of just being open to whatever you're saying and not trying to immediately judge it. You know, it's very hard, and I agree. You know, one of the reasons that it is hard. It's hard to talk about feelings. It's hard to listen. And so this workshop that I said, it takes 2.5 days. You spend a good part of that just going through practices and skill building in terms of how to do this. One of the things that came out of this at Harvey Mudd was that we realized that after we talked about it for a couple of days, at the end of on the third day, on the morning of the third day, what the facilitators will do is they'll bring back some students who were here at Harvey Mudd or at Purdue. These have to be alumni because what they're asked to do is very difficult, and so you don't want to put a current student in a vulnerable position. But you make a little circle of the students, graduate students, undergrads who were at my school before, and a facilitator then works with them and just asks them, so how did it feel to be here at Purdue? How did it feel to be in Asai's lecture course or his lab, or in biology as a graduate student there? And the rest of us, as a fishbowl, we're all sitting on the outside and we're listening. And it takes us 2 days to get to the point where we can listen without immediately responding. And what you hear is just incredible. How it felt to be, in this case, how it felt to be a minority. I think I'm cool as a professor. That's not necessarily how they felt about being in my department or being in my class. And it takes you that long, it takes us that long to get to that point where we're able to listen to that. Sometimes it works and sometimes it doesn't. But that's why these listening exercises are really tough. What happened at Harvey Mudd actually was that we did this and everybody's crying and everything, right? And then one of the things that came out of this had to do with a young assistant professor in math suggested, she said, we don't have to give homework on the weekends. Harvey Mudd is all about homework. You're not a tough professor if you don't give homework. And you got to give homework over the entire weekend because, right? Well, a lot of our students go home to deal with their family on the weekends. First generation students especially. There's no reason that I have to give the homework on the weekend. I can just add a little bit more homework Monday through Friday, but there's no reason that they have to do homework on the weekend. It's not about me. It's about what works for them. And so we did this really simple thing. No homework on the weekends. Didn't cost anything. And it was a profound change in the way we could think about our students. 1 or 2 more comments and then I'll shut up.
Yeah, one point similar to Corey's is that if in talking across difference, where you have a minority student talking to majority faculty person, so there's already that dynamic of privilege and not. If you perceive that the listener may not really be listening, by no reaction, no engagement in the conversation, then you may go away thinking that they really don't care, and then you don't go back.
Yep. One of the things that you learn is that when a student comes into your class and you've got your computer open, you really want to show that you're listening, you shut the laptop. Right? It's a simple thing. So look, I've had fun with you. I really appreciate your patience and your time. What I've tried to suggest to you, and what I suggest to every university where I give a talk, is that we have this enormous opportunity in terms of the kinds of students who are coming to our colleges wanting to study STEM. A lot of them don't look like us because of their backgrounds, because of their economic backgrounds, because of their first generation, because they're minorities. And it's important for us who work at a university, who define the university. You know, students come, students go, right? But we stay here. It's our job, I think, to take some of the responsibility and to say, you know, this is who they are, and we need to be able to be better listeners, to understand how they're feeling, and to think about those things. So I know that Michigan State is doing a lot of stuff in terms of your curriculum. I've spent the last day here hearing about all the curricular changes and the work that you all are doing. That's wonderful, and that's terrific. But it's more than just the curriculum. I think it's also faculty development. I think the faculty have to learn how to get better, and it's not just listening to me for an hour and a half. It's actually engaging in some of this work, just as you have to build skills in your own discipline. So I want to close then with a quote from yet another Supreme Court justice, in this case, Sonia Sotomayor. She wrote this as a dissenting opinion in the Schuett case. This was the case that sort of upheld the University of Michigan affirmative action case. And I'm just quoting from her, and this is very moving for me. And race matters for reasons that really are only skin deep, that cannot be discussed any other way, and that cannot be wished away. Race matters to a young man's view of society when he spends his teenage years watching others tense up as he passes. Race matters to a young woman's sense of self when she states her hometown and then is pressed, no, where are you really from? Race matters to a young person addressed by a stranger in a foreign language, which he does not understand because only English was spoken at home. Race matters because of the slights, the snickers, the silent judgments that reinforce the most crippling of thoughts, I do not belong here. So, race matters. Thanks for your time. Good luck here. I don't know what our schedule is today, but I know I've gone long, but I'd love to talk with you some more if you want to.
So we actually have until 1:30 for people who'd like to stay and ask questions, but I know some people may have other engagements, and please do feel free if you need to. Please feel free to take some food on your way out, so we don't have to eat it. But are there any questions for David? Or comments?
What is your name?
My name is Deidre Eatman. I'm Associate Director of the Academic Support Program here on campus.
You said that there's not a lot of data about the biased expectations for students and the ways that African American students publish. Do you have any information about how frequently they submit but are not accepted versus whether or not they submit in their research?
I don't have those data, but that's an important, that plays into expectations as well.
Other questions or comments?
Thank you, David. It's a very interesting talk. Much of the stuff you're talking about, Seymour Hewlett identified 20 years ago, and they weren't identifying in the context of race or underrepresented groups explicitly. They indicated that, as you pointed out, we weed out large numbers of majority students also. And so I guess the question is, why in 20 years has nothing changed? And as you mentioned, is professional development. We select faculty through an evolutionary process that the ones that survive this process go on to become graduate students who survive that process and go on to become faculty members. And so the whole process of getting a PhD is research intensive and not teaching intensive. So here at MSU, we try to spend a fair amount of time doing graduate student professional development and hope that that will help future faculty. Have you looked at trying to put your effort into the future faculty development?
Sure, and we are doing that also, but I think the message I was trying to say, and I think the reason we haven't changed in 2 decades or in 600 years is that up until now, we've been able to get away with a 60% attrition rate, an 80% attrition rate of minorities. Because up until today, the system was robust enough where it didn't matter. We could get along without 80% of those minorities. But as the demographics in this country changes, and if we think about the future of our professions, I think that it's sort of coming to a crisis which maybe we could ignore 20 years ago in terms of how we teach. And so I think that all of the things that this university is trying to do in terms of engaging all students in the way you learn STEM, I think is really important because it means that you're trying things that perhaps you weren't doing 20 years ago. So I'm not answering your question, but I do think that times are different today than they were even just 2 decades ago. And if we continue to go along as we have, then we're going to run out of talent.
Hi, I'm Melanie Cooper from the chemistry department. I guess I want to follow up a little bit on that. You said in your talk that faculty need to become more engaged and to change the way we behave. But in fact, those of us who are in the room are the choir. Whenever I go to any of these meetings, it's always the choir who are there. And I'm sure you see this as you move around as well. So do you have any thoughts about how we might change the culture so that it's not just the choir who gets engaged?
So the choir has to practice as well. And so that's important. And I think you begin with the choir. I talked about these faculty development workshops which were run at Purdue, for example. And these were a series of workshops in which it started in engineering and then moved over to the College of Science and then agriculture. And the goal was to involve all faculty in one of these workshops. You can do about 40 people at a time in a workshop. So you have to do dozens of these workshops in order to get through the whole faculty. But I saw profound change amongst my colleagues, those who were part of the choir and those who were not yet part of the choir, who never were but part of the choir. But I saw some positive change in virtually everybody who participated in these things. And so one approach is that you start off with the choir, and the choir has to see that this is a useful thing to do. And then if that's the case, then the leadership of the university, or in our case, the deans of the colleges, made it an expectation it's a leadership development opportunity. It's you're a leader or a future leader of our college, of our departments, and so we would like you to take part in this, and we're going to make the time for it, and we'd like you to devote 2.5 days to this kind of work. At a small place like Harvard-Mudd, we were able to get through all the faculty in 2.5 workshops, 2 or 3 workshops. At a large place like Purdue, it took years, and I don't think they ever got through everybody. But I get your point, and I agree, and I am a believer in these kinds of skill-building workshops. And I do think you have to start with the choir, but you can't just stop there.
Hi, I'm Julie. I'm from lots of spaces, but geology. And I'm speaking from a place of privilege because I have tenure, right? So what I see is that an institution like this values diversity and engagement and outreach and access, but really values research dollars. And so I wonder what advice you have for an institution in terms of structural changes that would encourage faculty to do any of these things. Because honestly, most of my colleagues aren't going to, because they have to get the research dollars and they have to publish the papers, and that's what's valued. And not that that's a bad thing, that's the reality of this institution. So what would you say to the institution?
Well, it depends upon who in the institution I'm talking to, but certainly part of the message is that if you think, if that's been your business model up to now, you best get a new one. Because the research dollars are going away. I don't know if you've been looking at the federal budgets, but we have. And I know at the NIH, it's hard, it's incredibly difficult now to get an RO1. And the NIH is a large, supporter of biomedical research at this place. NSF is the same thing. So the win rate, the hit rate is now below 10% at those places. So if my business model at a university is that we're going to continue to use the faculty to generate research dollars, from which I'm just going to get overhead, and we're going to continue to do this, I think that's a strategy with no future. This university is beginning to rely more and more on tuition dollars. Your state support is dropping, and actually you're not nearly as low as it is at California, Indiana, and other places, where the percentage now of the state support for the state universities is dropping down to the single digits in terms of percentage. And so tuition dollars become really important. And if your business model is that you're bringing in 40% of all the students want to study STEM, they're all paying tuition, presumably. And if that's a larger part of how this university is going to survive, and if you're pissing off 60 to 80% of those people who are coming in, then you're losing those tuition dollars. Now, I don't know about Michigan State, but certainly at a number of other places now, they're looking at performance-based funding in terms of distributing central resources. And so the number of students who stay in your classrooms and are retained become a budgetary part of the calculation, part of the algorithm. And the amount of money then that your department gets or your college would get depends upon how many students you actually are able to keep in the seats. And if you do the arithmetic, it actually turns out that an effective teacher that can hang on to a larger proportion of her students actually is worth more than an NIH grant. So, it's easy for me to say this. I know that, right? And so I get everything that you're saying. But you asked if I had a conversation with your university leadership, I would tell them that. I would ask them, I wouldn't say it quite that way, but I would ask them, what's your plan 20 years from now? When the demographics of this country, even Michigan, you only have 12.5% minorities on this campus now, but even Michigan, even the upper Northwest, the demographics in this state, as you know, are rapidly changing, and so you're going to have a lot more first-generation students, a lot more students of color. Your faculty remains at whatever it is, average 6% or so minorities. And if those students are going to be driving more and more of your budget because of the tuition that you expect them to pay, what are you going to do to keep them here? Why can't they just go online and just take a MOOC? And so my feeling is that a large number of the smaller schools in this country will go away in 20 years. Michigan State won't go away, but I think it'll have to change. And you ought to change. Hell, you are one of the leading, you're an AAU institution. You're one of the top 60 universities in this whole country. There are 1,800 colleges and universities in this country that give baccalaureate degrees in sciences. You're one of the top 60. Wow, what an opportunity to really show the other 1,799 how to do it better. So, sorry.
Great.
I get excited. Yes?
There have been some papers in Nature and Science lately about how the state of the job market for PhDs in science is fairly dismal. So I was wondering whether you think that has an effect on recruiting first-generation students and students of diverse backgrounds into PhD programs. If you'll be a postdoc for 10 years and never get a job, then is that really attractive to somebody who doesn't come from a well-supported family background?
Absolutely. And that's actually not a new phenomenon. You know, about 10% of our PhDs in the sciences will go on and get an academic position, a faculty position. So the other 90% are getting jobs elsewhere. And as you know, and a further complication when you're talking with young students who are starting off in college, often first generation, often immigrants, as we know many of the minorities are, there's a strong pre-professional drive. And so what are you going to do to take care of your family when you get out of college? So all of these things, and you know, President Obama is not helping here, right? Because he wants to rate colleges and universities based upon the kind of salaries that people will get once they graduate. So you get just, you know, that's just what he wants to do. But I shouldn't have said that. But nevertheless, if you can understand where people are coming from. And so I think that part of our job is not to is not to discourage students from aspiring to whatever they want to become, but to inform them about what their other options are. And you and I, we all know that we faculty we don't know how to get a job in something else because we happen to get a job doing this. But the fact is, as I said, that only a very small fraction of those students, far less than 10% of the undergraduates, it would be 1/2 of 1%, would actually, become like us. And so I think that it's important for us to educate ourselves. This is a form of skill building. This is a way of educating ourselves so that we can work with those folks.
Maybe one last question, if anyone has one.
Part of my strategy is to give really long answers to discourage questions.
Well, it's not really a question. It's more. I mean, I have a question for me, but it's more a comment. I mean, I got the impression that you focus very much on, say, race matters, but for underrepresented minorities. Now, the race, I think that at university there is also the international students. There is the diversity which is brought to university through whatever, Latinos, I mean, but students who come from South America, or the same happens in Europe, so African that go to Europe for historical reasons. But and somehow the universities do adapt, I mean, or try to make so that faculties are aware of this diversity, the richness of the international students, and the faculty then adapt to these or try to do their best. But and then, of course, I mean, respecting diversity, respecting races, respecting different religions. But there is a major difference is that I see, at least, that international students are generally very wealthy students, and of course, they're rich students, wealthy, which may be a major difference compared to the students from underrepresented minorities in the U.S. So what I do see there is that maybe there's a difference which is more in the social origin of the students rather than in the race. So that I have the impression that the institutions do adapt easier to students who are international, even if, than to students that are, say, national but from a different race. It's more a social origin that is touching there than the race. I'm not sure.
Yeah, I mean, so diversity is important. And you can measure diversity in any number of ways, including, for example, people from other countries, international students who might come to here for school, persons with disabilities, gender, sexual orientation, height, color of their hair, any number of ways. This is all beneficial to scholarship and to science. So these different perspectives is very important. Older, younger, and I'm not trying to discount that at all. But when we talk about race and ethnicity in this country, and what I've been focusing on are the folks who are in the United States, most of them are citizens now, and that they are a large part of I think, our responsibility to work with in terms of education. And so a university, I would hope, would try to achieve as much of diversity as it can in any number of different ways, including international students, all the other things. But we should not ignore the large number of students of color who are from this country. And indeed, a land-grant university has an obligation to look not just at students who might be coming from abroad, but also the students who come from the state of Michigan. And so that's a huge talent pool that, in my data, we're just talking about US students, that's a huge talent pool that we're not capturing, that we're not taking better advantage of. If we knew where the next scientists are going to be, where the next great scientists are going to be, if we knew what high school they're going to, if we knew what they look like, our job wouldn't be too hard. But we don't know that. And so I think if we ignore half of the talent pool, then that's just not a plan with any viable future in my view. And HHMI is all about trying to promote the best science, and so we need the best scientists to step up. So anyway, thank you very much for your time.
Thank you.